Electronegativity Part 1 video, we discuss in detail meaning of the electronegativity and polarity with plenty of examples. We also did difference in electronegativity and electron affinity. In electronegativity Part 2, we will discuss the factors controlling the electronegativity, in which we will discuss variation of electronegativity with atomic size and variation due to closeness to the noble gases in the periodic table. We will also do the range of electronegativity, the highest value of electronegativity and the lowest value of electronegativity on the Pauling scale. The difference in electronegativity of metals and non-metals, and why metals have less electronegativity and non-metals have high electronegativity, followed by plenty of practice problems and an interactive quiz. Now we are going to discuss the factors controlling the electronegativity of atoms of different elements. There are two major factors. One is the position of the element in the periodic table. Position of the element in the periodic table is going to control the atomic size of the element and is also going to determine the proximity of the element to the noble gases. This is one of the major factors which we are going to discuss in detail with different examples. Second factor is the surroundings of the atoms in the molecule. Atoms can have different hybridization in different molecules, and hybridization can change the size of the orbitals participating in chemical bonds. And size is the major factor controlling the electronegativity of the atoms. Other is oxidation number of the atom in the molecule. Higher the oxidation number, smaller the size, more electron hungry is the element, and higher the electronegativity. We are going to discuss all these factors in detail with different examples. Let's discuss electronegativity based on the position of the element in the periodic table. Two major factors, atomic size and closeness to the noble gases. First, we will discuss the variation of electronegativity with atomic size using different examples. We are taking very first example of boron and carbon atom. Boron is bigger in size than carbon atom. The electron pair shared between boron and carbon for making the chemical bond is more closer to the nucleus of carbon atom because of its smaller size. So it means nucleus of carbon is exerting more attractive forces on the shared pair of electrons. This results in a partial negative charge on the carbon because electrons are more closer to the carbon nucleus, and a partial positive charge on the boron as electrons are slightly away from the nucleus of boron. So now we can say carbon is more electronegative than boron because of its smaller size. Another example, oxygen bonded with carbon. Oxygen is smaller in size than carbon. Electron pairs which are present in the center as a chemical bond are more closer to the nucleus of the oxygen than that of the carbon. It means the nucleus of the oxygen is exerting more attractive forces on the bonded electron pair than the carbon. As a result of this, there is a partial negative charge on the oxygen, a partial positive charge on the carbon, because electron density is more closer to the oxygen atom and electron density is less on the carbon nucleus. It means oxygen is more electronegative than carbon. So we can say that smaller the atom, higher the electronegativity, and bigger the atom, lesser is the electronegativity. As we know, the atomic size down the group increases in the periodic table and along the period atomic size decreases. So it means electronegativity down the group is decreasing and along the period is increasing. Calcium less electronegative than bromine. Oxygen less electronegative than fluorine. Boron less electronegative than carbon. We'll discuss the second important factor which controls the electronegativity, and that is the closeness of the element to the noble gases in the periodic table. Noble gases are on the extreme right side of the periodic table. In general, periodic table can be divided into two major parts, metals and non-metals. Non-metals are on the right side of this line. Metals are on the left side of this line. Now, what is the basic difference in metals and non-metals? Metals lose electrons to get the nearest noble gas configuration, whereas non-metals, they gain electrons to get the nearest noble gas configuration. Example, sodium is losing an electron to get nearest electronic configuration similar to neon, so it's a metal. Whereas chlorine gains an electron to get electronic configuration which is similar to argon. So it's a non-metal. Bigger the size of the atom, more it has tendency to lose electrons because valence electrons are away from the nucleus. So they are less tightly held, so less energy is required to remove. Smaller the size of the atom, less it has tendency to lose. More it has tendency to gain electrons because valence electrons are closer to the nucleus and they are more tightly held by the nuclear charge. Down the group, atomic size increases. Along the period, atomic size decreases. So what does this mean? It means most metallic elements are on the extreme left side of the periodic table and most non-metallic elements are on the extreme right side of the periodic table. So alkali metals, which are the most reactive metals, and seventh group halogens are on the right side, which are the most reactive non-metals. So in general, we can say non-metallic character increases along the period as the atomic size decreases, and metallic character increases down the group as the size increases. Very reactive nonmetals, halogens, and very reactive metals, alkali metals, are closest to the noble gases. But halogens are most electronegative in their respective periods, and alkali metals are least electronegative in their respective periods. So in general, we can say non-metals are more electronegative than metals. Non-metals closer to the noble gases are the most electronegative. Metals closest to the noble gases are the least electronegative. Fluorine, chlorine, bromine, iodine are the non-metals closest to the noble gases and are the most electronegative elements in their respective periods. Whereas metals, lithium, sodium, potassium, rubidium are also closest to the noble gases, so they have the least electronegativity in their respective periods. Let us compare the electronegativity between the bonded atoms based on their position in the periodic table. So we will compare their atomic sizes and their proximity to the noble gases. In atomic sizes, bigger atoms are less electronegative and smaller atoms are more electronegative. Non-metals are more electronegative and metals are less electronegative. Let's start with carbon and hydrogen bond. Carbon is more non-metallic than hydrogen. Hence, carbon will be more electronegative than hydrogen and it will pull the shared pair of electron density on itself and will acquire a partial negative charge. Hydrogen will acquire a partial positive charge. Let's compare nitrogen and oxygen chemical bond. Oxygen is smaller in size than nitrogen. So oxygen is more electronegative than nitrogen. So it will pull the shared electron density more on itself. So oxygen requires a partial negative due to high electron density. And nitrogen requires a partial positive due to less electron density. Another example, boron with fluorine. Boron is bigger in size than fluorine because of its position in the periodic table. Fluorine is more electronegative than boron, so it will pull the electron density on itself. Boron with hydrogen. Boron is more metallic than hydrogen. Hydrogen is more electronegative than boron, so it's going to pull the bonded electron density on itself and acquiring a partial negative, and boron will acquire a partial positive. Actually, hydrogen is less electronegative than carbon but more electronegative than boron. This is the point which you have to remember also, because boron hydrogen bond you can see in many organic reactions. So you need this information in many mechanisms. In boron hydrogen bond, remember, hydrogen has a partial negative charge and boron has a partial positive charge. Whereas in carbon hydrogen bond, hydrogen has partial positive and carbon has partial negative charge. Now lithium and carbon chemical bond. Lithium is a metal and carbon is a non-metal. So it means carbon is more electronegative than lithium. So the electron density will be more in the direction of carbon. So carbon will acquire a partial negative and lithium will acquire a partial positive. Similarly, oxygen and sulfur. Sulfur is bigger in size than oxygen. So oxygen is more electronegative than sulfur. Oxygen acquires a partial negative and sulfur acquires a partial positive. If I compare lithium and copper, both of them are metal. Lithium here is more metallic in nature than copper because it can easily gain the nearest electronic configuration, noble gas electronic configuration, only by losing one electron. So lithium is less electronegative than copper. Or you can say lithium is more closer to the noble gases, so it is less electronegative than copper. So there is a partial positive on lithium and a partial negative on copper. Lithium carbon bond or any metal bonded with carbon. Remember, any metal bonded with carbon will make carbon partially negative, because in that case carbon is more electronegative than the metal. This is very important, which we need to know for many organometallic bonds or chemical reactions. Thank you for watching this video. In electronegativity part 2, following topics are covered with plenty of examples and practice problems. Factors affecting electronegativity like atomic size and closeness to noble gases in the periodic table, range of the electronegativity and the difference in electronegativity of metals and nonmetals. If you want to practice more questions on the same concept, please click on the link given below. You are most welcome to ask your doubts or questions in the comment section of this video. In electronegativity part 3 video, we will discuss difference in electronegativity, and based on that, we will identify polar bonds, non-polar bonds and ionic bonds. Range of electronegativity from most electronegative element of the periodic table to least electronegative element in the periodic table, followed by practice problems and interactive quiz. You can click on the link shown here to go to electronegative part 3. Links to notes and questions have been provided in the description below. Please like, share and subscribe, and do not forget to click on the bell icon to turn on notification.